Hello? Still nothing? Okay. Yay, we have sound. Hi guys. How you doing? I'm Tony. Tom's over there. Stephanie's back there. Let's just hang out a little bit because it's not 11. And then we'll start. Today we're going to go over the mod tools and an introduction to scripting and sort of take you under the hood a little bit. Yes, I do exist. I'm the lurker of the company. Tom's really out there sort of getting the word out and doing more videos and AMAs, and I'm in the corner hacking away, trying to make progress on the game. He's the outward face of the company. I'm the little squirrel on the wheel. So, as long as you're waiting, I'll answer 2 questions, and then we'll get going. Since we have 1 minute, maybe 1 question. First one in. Code monkey, yeah, that's me. 4-player co-op. Oh, I'll punt that. Looks like why choose Lua got in first. Lua's great. Actually, that's good because it goes right into the presentation. Right? We want people to be able to write scripts in a very friendly language. Right? Like we use C++ for all the core stuff for speed. But the scripting stuff doesn't have to be that fast, and C++ isn't that safe, right? We don't want people downloading binaries that just some random guy in the mod community compiled. So Lua is interpreted, the sandbox is very small, and the language itself is very small, but has some key features that we need, primarily coroutines, which lets us do basically a shared multi-threading environment, so every little actor gets their own little stack and their own little environment to run in, so if one actor crashes, the other guys aren't affected. And it has lexical closures, which make it really easy to make, sort of callbacks and stuff. So if you like Lua, great. If you don't like Lua, learn to like it. It's not that bad. Or hopefully you'll like it by the end of the presentation. So let's see. Does this work? Is the game running? Yeah, right. This is the game. This is the same build from the Kickstarter. Right, so you see bunnies and people. What we're going to be doing is adding the mammoth pet to this game. So I'll get it running, right? So you see it still works. They harvest. Like we've added a little bit of UI just for fun. And so what's the mammoth pet, right? That's one of the rewards for the Kickstarter tiers. And a few streams ago, Tom actually modded that up, right? So let's get rid of the game, and I'll show you. This is the mammoth. If I can drag this over. No, that guy, right? So say hello to the mammoth. Tom modeled this up, and showed you how the mammoth has already been cut into bones, right? So here's his head and his feet. And he animated it. If you want to check out those live streams, they're in the archive. But what we're going to do is actually add him into the game. So the first thing we have to do is export him. Alright, so there's this. Can you see that? Let me make my cubicle smaller so you can see everything that's going on here. Alright, so we do export all. And cubicle is this great tool, right? I don't know where we'd be if not for cubicle. We'd have to invest a lot of energy in our own tools, and this just lets us bootstrap really fast. So where should this go? Let's put it in Stonehearth data. So this is the data directory, right? All of our mods and all of the code for the game actually lives in the data directory, right? And so I'm exporting the QB, and I'm going to put it in this directory for the mammoth, right? We're actually modding in a new mammoth, and he gets his own directory. I'll go over exactly what all this is in a second, right? But and we want to use a cubicle binary format. That's a binary exchange format written by the makers of Cubicle, specifically for getting data in and out, right? There's all these settings we have to use. Left-handed RGBA. Let's just skip over them. It's not sort of interesting. So there we go. So that took the mammoth out of Cubicle and put it in a format that we can understand in-game, right? Let's kill him. So let's look. So this is the directory, right, we just made. Here's the mammoth KB file. It's in binary. It's not useful to look at in an editor, but in order to get him into the game, we need to make a sort of a description of how to load the KB file and how the mammoth will behave, right? This is the script directory itself, right? If you haven't seen this tool, this is what's it, Slick Edit or something? Sublime Text 3, right? Which is cool. It has a little explorer and a text window on the right-hand side. Tour the data directory, right? This is where everything in the game lives, right? So, for example, you see the critters directory. Here's a rabbit, right? This is the rabbit QB file. That's the model that exported from the rabbit QML file, right? And here's the .text file that describes everything that's in the rabbit, right? So we're going to write one of those for the mammoth. So the first thing we do is, let's see, can you find in this thing? There we go. And all of our descriptor file formats are in JSON, or JSON if you prefer. And we use an entity component framework. It's a fairly common framework for writing games where each game object is just sort of this empty shell, and you add functionality to it by adding things called components, right? So the mammoth is, a game object, so he has to be of type entity, right? And the first thing we want to do is, like we said, describe how he gets rendered. So we have this render rigs component, and let me make sure I get this right. So we want to say this mammoth is made up of a couple different models. And now we want to say the first one is just the mammoth that we exported, right? So we use this sort of HTML syntax, not HTML, but sort of a web framework syntax for referencing things in the data directory. So I want to say it's a URL which is relative to the current directory, and it's just that mammoth.qb file, right? So let's save this as the mammoth guy. And so now we have like sort of a description of the mammoth. There he is. So let me check chat for a second. Non-programmer versions like the Portal 2 Lover Maker? Yeah. So this is easy, right? Like you can read the text file. If you're scrolling around, like you want to see the rabbit, like here's another entity for the rabbit. It's a little more complicated, and we'll get to here eventually in the mammoth. But it's sort of cryptic and annoying and an error-prone way to do stuff. We want to have tools for all this, and we'll get there eventually. But right now, everything is done in text editor or cubicle, right? It would be really easy to like sort of like say, oh, make me a new entity, and then click render rigs. Unity does a great job of this, right? If you've ever played with the Unity editor. But we don't have that tool yet. We want to build it. It's a big priority for us. Why .text instead of .json? Because I can double-click on a text file and it opens the right editor for me. That's really the only reason, right? Like you can see when I refer to this URL, I refer to mammoth.qb. Like we sort of load resources and refer to resources by URL. So I could have said load. Eventually you'll see when we load the entity, we have to refer to this file. And you could have just called it .json, and we could refer to it as mammoth.json. But .text works for me. I don't know exactly how firm we're going to be as opposed to your file association must be this, and your directory structure must be this. Obviously, we'll have recommendations for when you're writing a mod, so that when you get a mod from someone else, you sort of understand where everything lives. But we don't want to be firm on that. Yeah, so what can we do with this mod? Well, we'll find out by the end of the broadcast, right? But so that's got the mod. Now we have to get it in game, so we can actually see what happened and see if it works. So you saw the game. We don't actually do most of our testing with the game running. We use these little sandbox tests. So you see these things called Stonehearth test. That's actually not the right folder. Let me find the right one. I'll show it to you in Dakota, right? Right. So this is a little class we wrote called Harvest Test. which essentially is a really tiny instance of the game, where all it does is create a tree, make a guy, and then place a stockpile down 10 milliseconds into the game, and then harvest the tree, right? So this is a really small test that lets us test just the harvesting functionality. And let me actually, I'll edit the, so there's a config file off screen that I'm editing to actually load that instead of, oh, where'd it go? We're going to run harvest test instead of the actual game, because it's really hard to debug with like thousands of entities loaded. We just want to load the mammoth. So where's that source? Client. There it is. Okay. Sorry, I thought I had that file loaded, but it turns out I didn't. Right. So here's the harvest test, right? Actually, let's see if we can do it this way. Right. You see the guy, right? This command, like, place stockpile. You see that's the stockpile that got put down, right? We put a tree down at -12, -12. There's the tree, right? And this guy that we put down, here he is, and he's doing the harvest command, which we asked him to do, right? So we have like a whole slew of these little tests. One for just testing building, one for just testing, you know, the carpenter guy. Although the carpenter guy is not public yet. And so we can make a new test, but let's just modify this one, since I have it running, to actually load the mammoth, right? So we can come back here and say, we still want to create the world, right? But let's take out all this functionality with the tree and the person and stuff. So what I've done, that's a block comment in Lua, right? Take all that code out. And we want to create a mammoth, so we'll say mammoth equals, and we want to load an entity, right? So we'll say OM is the object manager. A lot of this stuff will be greatly simplified. You're sort of looking at the lowest level programming layer. We want to create higher level abstractions for this to make it easier, but for the time being we can do, let's see, OM. We want to create a new entity. So that'd be create entity. And we have to point to the mammoth that we just loaded, right? If we go back to Sublime Edit, right, we have our, right, the text editor, we have to get to this entity file we created, right, mammoth.txt. So we have to give a path to it, and that path is actually in Stonehearth, critters, mammoth, right? Because if you go back to the other folder, right, there's the Stonehearth directory and the critters directory, and here's the mammoth, right? So that says load the entity in this directory, right? If we want to get a rabbit, we could have put critters rabbit, but we don't want a rabbit, we want the mammoth, right? And so that gives us our mammoth, and then we want to place it in the world, so we can do place on terrain the mammoth, and let's just put him at 808, right? So no semicolon in Lua. That will put him somewhere in the world around 88, right? Which is probably right around here. So what program is this? This is Dakota. Dakota is the best Lua debugger on the market right now, I think. So we can like set breakpoints, and there's a breakpoint. We can like watch windows and stack and stuff. And I'm doing it in Dakota so that if we have an error, like it pops up instead of the game just doing something cryptic, right? So the tools that we generally use are Tom will use Cubicle Constructor and 3ds Max for animation and and modeling, and then I'll use Visual Studio for programming the C++ side, and then Dakota for debugging the Lua side, and just any random text editor for editing the Lua side. Although Dakota is also a great Lua editor. So let's see if this works. Let's kill the game and run it again, and I'll run it in Dakota actually in case I screwed up some syntax, right? But yeah, we're running the harvest test, and nope, died. So he did something horribly wrong, which happens. So let's set a breakpoint, see what happens. I'm betting that either, let's see, we create the mammoth, nope, game dies. So there's something wrong with my mammoth syntax. Let me actually check that out. Redirects mammoth URL. Nope, seems to be fine. So I have prepared for this eventuality. So one of the things we haven't done a fantastic job with is all the error checking that you would need. We do some error checking, but generally the result of that error checking is logging the error and dying. Right. Eventually, of course, errors will ripple up and do the nice thing. World of Warcraft does a great job of this, where if you've done any modding there, like it tells you exactly what you did wrong in your mod, and then eventually asks you if you want to kill the mod because it's consuming too much resource. That's what we want to do, of course. We're not there yet. We'll get there. Right. This is a really early look. Let's see. Stonehearth 2. So look at data. Stonehearth. Mobs. Nope, critters, mammoth, the text. So this guy. Alright, so if you slam that and get rid of that. So I know that one works. Looks the same to me. But, so two scripts. Test, harvest test. Nope, nope. Yep. This guy. Interesting. Looks the same. Yeah. Alright, there. Don't know what changed, but it appears to work. Right, so we've got our mammoth. There he is. Yay. Yay. Alright, if you're asking for anything, alright, so this is a good time to pause and take questions. Because I went through that super fast, and if there's anything you don't understand, then let's stop now. Because basically what we did is we took Cubicle, we exported a model of the mammoth, we referenced that model of the mammoth in a new entity file that we created, and then we loaded up our little test framework and loaded the mammoth and put him in the world. You erred because you placed the mammoth into the ground. No, yeah, the mammoth, the ground placing code is smart enough to put things on top of the ground, so that's not the reason it was crashing. I'm not exactly sure why it was crashing. Yeah, I know I said 8-0 minus 8 in one and 8-1 minus 8 in another, but it turns out that doesn't matter. The y coordinate is just the base, and then the game will move people up until they're standing on the ground, until they're actually in the ground. Are we going to support dynamic updating of your Lua code? Are we going to leave it so you have to reload Stonehearth every time? We want to support it. That's a very hard problem. The answer is yes, but it doesn't always work, right? For example, here's the mammoth, right? I've said, oh, look, when we start giving him behaviors, like he'll run around and he'll jump, hopefully, if we get that far. And we might put him in a state where if we were to dynamically load the Lua code, like the new code doesn't expect the old state and it will break. But like World of Warcraft has this feature where you reload the UI and the whole UI reloads, but at least you didn't have to reload the whole game. We want to have something similar to that, where you reload just a small subset of what you need so that you can really iterate very quickly. Because that's the most important thing, right? When you're writing new code is, like, how long does it take me to sort of write something, test it, realize what I have to fix, and then go back again, right? The faster we can make that, the easier it's going to be to mod. So really tactical question asked, are place citizen and place tree essentially shortcuts to create entity and place on terrain? No. The formal API is still being defined. Let me actually go into that a little bit. What you're seeing is the lowest level coding API that we're using in game. We want to wrap that in something that's very friendly and very well documented. So right here, the GM is the game master. That's the game master UI that sort of decides, well, you know, when are things going to come in? When are people going to invade your town? You know, is it going to rain, right? It's the global game master, right? The OM is the object model, which is used to create objects, right? So when I say OM create entity, right, that's actually a very low-level call, right? A lot of this stuff has been wrapped, like OM place on terrain, very low-level call, right? So they're not synonyms, right? Place tree, though, is actually a call that was implemented by our superclass, which is microworld, which I can show you really fast. It's a helper. Is it in here? No, it's not in here. Let's see, is it in here? Microworld, right. Microworld is a helper that we wrote to help making like these little worlds, right? So you can see, is this cleared? There we go. Here's microworld place tree, right? Can you guys see my cursor? Let's see. It doesn't look like it. Okay, I'll keep using the whiteboard. Nope, no cursor. Alright, then I've got to use the whiteboard, right? So here's place tree, right? And it calls self place item with a URL and then an XE coordinate where place item says, right, here, create entity with the name, really the URI, right? And then place on terrain at that location, right? So we've sort of built up this library of helper functions that we use to help us make this little world, right? But and really sort of this, you know, object model layer, game master layer, that's the lowest layer. But there's a layer that does not yet exist, which will be the modding layer, which will be a lot like microworld, right? Which has all these helper functions to make it easy to do things and only exposes the the safe, well-tested, you know, check all the parameters going in, give good error message going out layer, right? So that's something we want to build maybe before the beta, if not directly after the beta or during the beta, so that people can use it. Wow, why is everybody saying Tony, Tony, Tony? No, no, yes, yes. Summarize for me. Easy for is the lower, yeah, the lower level stuff is totally going to be available to you if you want to use it. There will be some lowest level API that you cannot go below, obviously, but all APIs will be stable. Because we want to be able to use mods. Like, we don't want to ship another version of the game and all the mods break, right? That's like the worst case scenario, right? Will the beta be a beta like Minecraft with updates? Of course, like we'll update it as frequently as we can, as both to respond to beta feedback and to fix bugs. Like, that's one of the reasons you do the beta, right? Is to get all the bugs out before the release. Have we ever considered a hybrid Lua Erlang scheme common Lisp API connector for crazy people? No, I honestly can say we have not considered it. If you want to compile your code to Lua from something else, like if you want to write in Haskell and get your Haskell to Lua compiler, go for it. You can totally front end that, but we consume Lua. Okay, let's move on. So we have the mammoth. He's just standing there, which is cool. But he's not doing anything, right? He has no animation. He's kind of boring, right? So let's actually start animating him and give him some personality, right? So the QB file just had a bunch of models in it, but like, how do you actually animate it? Tom actually took the time to break up the models and produce sort of these nodes and named nodes that we can then move around to make the mammoth dance. So we need to refer to that, right? If you look at the rabbit, we have this thing called animation table, right? So let's just copy paste that so I don't typo, right? The animation table, and all these names are placeholders really. It used to be just an animation table, and it's really more like a rig. It's a description of the rigging of the mammoth, right? And we have one for the rabbit. Like I can show that to you right now. Right? It's in the rigs rabbit, right? So it's got the type is rig. It's got a skeleton, which is all of the little parts of the rabbit and where they live in that cubicle file, right? And then an effects root, which we'll get to later, right? But like this file isn't produced by Cubicle currently, right? And you actually have to take your Cubicle and load it into a program like 3ds Max or Blender in order to figure out those offsets and then run a render or a converter script to actually output them. We wrote that script for Max. That's what Tom used in the previous live stream. Check it out if you want. So we need to write one for the mammoth, right? And let's say mammoth. And let's make a new one. So I've actually done that, and to speed things up, I'll just go ahead and copy paste that file. If I can find it, rigs, nope, not there. Okay, Stonehearth 2, data, rigs. Uh-oh. It's missing. There it is. Mammoth, so... Mammoth. Okay, so that should show up now. So here's the rig for the mammoth. You can see he's got like, a ton of more parts, right? He's got lower torso, back right leg, paws, heads, tusks, trunks, right? And those are the positions in the cubicle file where all those live, right? It also has this thing called effects root, right? Which is where the animations or the effects live, right? I'll show you a couple of those, right? Here's a sample effect, right? Breathe. All this is JSON, right? Everything that's data is JSON or compiled from JSON or a cubicle file, right? So, what's an effect? An effect is, well, what it sounds like, right? An effect, a visual effect, or an audio effect, right? And they run on these tracks, right? So, right now, the one we've written now, like it has a track. There's a single track called animation, which is also a JSON object. It's type animation effect. It starts 0 milliseconds into this effect. Here's the animation file to load, and it should loop, right? So this is the idle breathe effect, right? This is where the mammal's breathing in and breathing out. Right now we just have animation, right? But you can imagine other things here, right? Like if there was like a puff of smoke that we want to appear when the mammoth breathes, right? We would do like smoke puff. And then it would be like, there'd be stuff in here, right? Like, maybe the type is a particle system, right? Whatever, right? And then a bunch of stuff there, right? You can imagine, like, we wanted to snort, right? And that's, the type would be, play, sound, or whatever, right? So the effect file, I mean, if you're familiar with Flash and Director and stuff, you can think of it, or Premiere even, you can think of it as one of those presentations with all the little tracks and all the little things that have to happen in order to get this effect, right? And how everything synchronizes together, right? But for now, we just have animations, so let's just worry about that, right? So this URL syntax, right? I talked about it before, right? We use this syntax so that we can refer to things, with relative paths, right? So the actual keyframes and things to play for this animation are one directory up in the animations idle breathe directory, right? So there it is, right? It's of type animation, and it's got a massive number of keyframes, right? It goes on and on forever. Where animations, like we currently model at 30 frames per second, and output every frame and then just interpolate between the frames. That's working well for us. Like if it gets jerky or for some reason, we can use like a Bezier curve between things. But this is simple and it looks great, especially given our Voxley style. It's a little weird, like the difference between an effect and an animation. Like you always want to reference effects in your scripts. It doesn't really make sense to reference an animation. It might for now, because all he does is breathe. But the moment like you do a run animation, you want to add footsteps. Like, well, how do I refer to the footsteps? It's in the effect file, right? So whenever we do scripting, we refer to the effect file, which has a tracks, tracks of effects, one or many of which are animations, right? So let's pause for questions again. Oh, I see. There's a bunch queued up. Right. Let me see. Will there be mod collections like in Steam Workshop? Yeah. I guess I'm going to handle questions like that at the end. If you have questions about what I'm doing or you didn't understand what I said, like go ahead and shoot those out. And again, we want to have tools to make a lot of this really simple, right? You can imagine clicking on a mammoth and then seeing the effect track for all the effects you have, and being able to like drag and drop stuff around, like if the footsteps don't quite line up with where the animation is. We'll get there. It's just a matter of time. That's great. We have an animation effect for the mammoth, but how do we give him AI? Like, how do we make him think? And this is worth a segue in describing how our AI system works. Oh hi, look, webcam, I'm still here. Tom made this great slide for me. So every little creature in the world that can possibly think has this little AI system running in it. Each one is run in a coroutine. If you don't know what coroutines are, think of them as threads. So every little creature has their own thread of execution, and they all run independently. So they all have their own little brains, right? They all have their own little motivations for doing what they do. There are three basic parts, right? There are these things we call observers, where an observer is really looking out into the world and gathering information and digesting it and moving it, sending it downstream in a way that makes sense, right? Because you can imagine, like, there's voxels everywhere, there's creatures everywhere. What's actually important, right? So an example observer is, suppose you've got like a guy here, right? And he has a sight radius that's like this big, right? He's got a sight sensor and he's looking around. And he sees like, oh, there's a goblin here who's wielding an axe, and then there's a goblin right here who's got a sword, right? Like, that's sort of important information, right? There's these two guys who are threatening me or perhaps hostile to me. So an observer will like look at there's one observer in the world that looks at everyone in my sight radius, look at their faction. Like, these are both an enemy faction to me, so they're dangerous. So let me send downstream some information that this guy is 3 units away from me, and is, there's actually a table that says, oh, he's 3 units away. That means he's like a scary factor 100, right? And this is unit X, right? This is the big X. And this guy is like 6 units away, and that's so scary factor 20, and that's Y, right? And that gets sent downstream, right? So it's sort of like scary factor, 2 people. This guy's really scary, this X guy's really scary, this Y guy's not very scary, right? And that's sort of digesting information about the world and sending it downstream. An entity can have like a lot of observers attached to it, right? You can have an observer that says like, how sleepy am I? Like I'm a fisherman, I really want to fish, are there any pools nearby, right? They're essentially looking out into the world and sending information down to the intention system, right? And you can write observers, right? You can write new observers. If like you want to like make a jukebox mod, right, where anyone close to the jukebox will like start dancing if it's playing music, right? You can write an observer that looks for jukeboxes around and then sends that information downstream, right? So what's next is the intention, right? The intention system is looking at all the data that all the observers have passed and trying to make a decision about something that needs to be done, right? So, for example, you might have an observer, like the observer we had before, where it's like, hey, there's two creatures nearby, and they're both kind of scary, but this one's way scarier than the first one. There might be a defend myself intention, like a footman or a soldier. Someone might be like, well, you really should attack the scariest guy, right? Or you might have a run away from danger intention, like the workers who can't defend themselves. Say, find the scariest guy and run directly away from him. Or take the scary guys and find the center of mass between them and run away from that, right? Whatever, right? But the idea is the intentions take information from the observers and send them downstream in the form of an activity, where an activity is a priority and a name. So a priority, and the priorities are sort of weighted from 0 to 100, or 0 to 99. Sort of doesn't matter. It's Lua, I get confused. That didn't work out as well. Right, but essentially this is a number, and this is a name, right? A string. And then, so that's sort of like, you have all these competing things, right? It's like, oh, I want to go to sleep, but I'm also very hungry. But there's a goblin right there, right? And the AI system will be like, wow, the goblin right there is like super high priority. That's what we're going to do. And it will look up in the action database and say, like, this intention recommended that you attack this goblin. How do we do that? And it looks up the action by name, and then the action actually does, like, implements that limited behavior, right? So like draw your sword, run up to him, whack him, and actions can actually invoke other actions, right? It's like, you know, composition of functionality, because some actions might be very complex, like building a house, and some actions are very simple, like going to a location. But everyone who wants to build a house, or attack an enemy, or fish from a pool, or go to sleep needs to be able to walk somewhere, so they can all use that, the action of going to a location. So let me scroll back and hit some questions. Do they have default intentions, or can we implement our own observer events? All of this is meant to be moddable, right? So you can write your own observer, you can write your own intention, you can write your own actions that use the library of actions, or even actions you write. You can define your own activities, right? It's all namespaced, of course, right? There's sort of like, for example, I'll show you, we have an action called radiant.actions.idle, right? And so anyone who wants to idle can just use that action and be like, oh, why don't you idle for a little bit, right? Now, if you make your action, you better not call it radiant.actions.idle, because then it'll confuse everybody, right? But you can write your action and say, oh, I'm I'm HappyMan333, right? I can write a mod that has HappyMan333.actions.dance. And then you can refer to that internally, or other people who want to depend on your mod can invoke that action, right? So we're trying to do this in a way that is fully extensible, right? Which means there's a balance, right? We can just be like, here's the code, go at it, right? And then everything will break anytime anyone changes something. Or we can try to define like stable interfaces, like the interface between an observer and an intention. Like, that's an interface, right? So there has to be a namespace here, and like a well-defined object for how an observer says something about the world to an intention. And this is an interface, an activity, right? That's why it's just a digit and a string and some arguments that are string specific, right? So we try to define these interfaces and then let you go to town anywhere inside here, right? As long as you only talk to these components through these well-defined interfaces, like, you can do everything. That's the thought. Like, we'll see how close we get. At what level of atomicity is an action at? Like, build a house seems more like an intention. Get wood, however, yes, in fact, you are right. Build a house is an intention. It's not really an intention. Even that is too high of a level of an intention. But let's take a look at an action. Actually, we'll rewind it. Let's look at let's go to editor plus Tony. Right. Let's look at some actions. Right. So all of our actions. No, those aren't the actions. Stonehearth. Oh, wrong directory. Let's look at it in Lua. Alright, alright, so here's the idle action. Excuse me, right, a lot of this boilerplate, like, all that boilerplate is going to go away. We want to refer to actions by URI, right, where this script contains an action. So we would say run the Stonehearth actions idle.lua script, right? You second the silent output. You don't like my voice? How are we gonna? Oh well. So here the actions are an object which implement a run script, which take this AI parameter, which lets you do other things with the AI, and an entity that the action is running on, right? So this action is saying forever, like while true, see what we're carrying, right? And if we are carrying something, then you need to run the carry idle action, right? Otherwise, you want to run the idle breathe, right? And then this AI that executes says, remember that loop on the chalkboard? Like this loop here? We said actions can call other actions. That's the composition, right? So this says this action should run this action with this parameter, right? So I need you to perform the thing I decided about before. And what does perform look like? Well, funny you should ask. It's right here, right? So again, this is boilerplate. Ignore it, right? Perform says, remember we passed in this action, which is either carry idle or idle breathe, depending on what you're doing, right? And that's this action, right? So it says, remember the entity, remember the action, create an effect from the animation manager, and start the action that you did, right? So that will say, oh, suppose it was carry idle, right? Suppose it was carry idle. So it loads the animation manager for this entity, says, I need you to run the carry idle effect. So remember where we put effects, right? For rigs, a person, right? Here's his rig, his effect root directory. My phone is ringing. Not good. Should have gone silent. Alright, we're silent now. Right, in the effects directory, let's look that up, right? There's this thing called carry idle, right? This is the carry idle effect. This is the effect that it's going to run, right? So that it'll run this animation where the guy is carrying a block and just sort of, you've seen it, he's rocking back and forth a little bit, right? Which is actually sort of worth it. This is how we sort of make actions reusable, is if you had, like, say a horse that was carrying something and you wanted him to idle, or a cart, or carts don't animate, right? But suppose you had a mage worker, right? And the way he carries stuff is with a completely different idle animation, right? He's like levitating it in front of him. Like, because we only refer to effects by name, where the effect is rig specific, like you can use that code anywhere, right? So you can use this code for any rig that has defined a carry idle effect, right? Like you're gonna see with the mammoth, we have this. Oh, where are our effects? Where'd they go? Oh, it's in the rigs, right? So the mammoth effect has an idle breathe, right? Mammoth rigs, mammoth effects, idle breathe. Just like the person has a idle breathe effect. That's intentional. It's so that the code, when it says, "Hey, you need to run your idle breathe effect," it can either go to the mammoth one or go to the person one, depending on whether you're using it with a mammoth or a person, right? So back to the code, right? We load the effect, we start it, and then we ask the AI to wait until the effect is finished, right? I talked about closures before, why we chose Lua. This is one of the reasons, right? Because we can refer to this effect in this function. If that went over your head, don't worry about it. It's super important for me. Maybe not for you, right? And then we set the effect to nil, and the function returns. That means the effect is done. At which point we return back to idle, right? This is done, and then we go back and then we make up a decision again, right? So that's how idle works, right? Looking for questions. No more questions. Good. People are chatting. That's fine. So great. So that's idle. How do we make the mammoth idle? Well, that is a good question. How do we make the mammoth idle? No, not that. We use GitHub for version control. So we need to essentially, we have the mammoth's effect root points here, and we have the idle effect. So we just need to tell the mammoth that he's able to idle. So if we look at the critters mammoth directory, right, we need to give him some AI. and I'm pretty sure, let me double check, so I don't want to like crash again. That was embarrassing. So we can actually reference the rabbit and see what he does, right? In fact, we can just grab this, right, and say, here's the mammoth block, right? He has an intention, and let's just make him idle, right? That's all he does, right? This is a pre-canned idle intention, which just says, I'll show it to you, if we're lucky. That's the action. Let's look at the intention, right? Which says, again, this is boilerplate, ignore it. It's going to go away by the time you get the system, right? No, that's not it. Where is it? Is there an idle intention here? Let's see if find in file works. This sometimes works, sometimes doesn't. Oh, it didn't work. Where did I put it? Where did I put it? Observer? No? Okay. Visual Studio time. No, not you, not you, not you. Yeah. Oh, Dakota bug. Wow. So, because they're both named idle, Dakota gets confused. So, I can show you, it's in Stonehearth, scripts, gradient, intentions, or AI, intentions, idle. Alright, so here's the idle intention. Alright, again, this is boilerplate. Intentions just recommend activities, like we said before, right? And we want at the lowest priority for you to idle, right? And so there'll be this huge intention stack. You know, should I run away? Should I eat? Should I sleep? Should I cast fireball at someone, right? And so if all of those guys be like, nope, right, then idle wins because it's the lowest priority, right? And so people will always idle. And if you saw the idle script for the action just runs forever, right? This ensures that our civs are never zombies. They're never standing there doing nothing. They're always doing something, right? So I think that's it. I think if we just close that. If we just save the where'd you go? Critters, mammoth. All right. If we just save this and then run again, you should see that effect playing. And let's see what we got. Nope, didn't work. Oh, so disappointing. Let's try it in Dakota and see what happens. Create the world, create the mammoth, place them on the terrain. Run, Dakota, run. No? Confusing. No, it seems to have worked, and yet I see nothing. Okay. Well, let's try going to another backup. No, not you. Stonehearth. Why must you do this to me? So, as an aside, this is why people don't give live demos anymore on stage. Actually, I heard that at Google I/O, the Google Play live demo, they actually tried one and it didn't go off so well. But this happened to Bill Gates a while ago, my God, like early 90s or something, where he did a presentation and it didn't go so well. And after that, Microsoft just stopped doing live presentations. You do the canned one, right, where it looks live, but it's not. So I was going to say, oh, that's no worries. I can just write code on the fly and make it to work. That didn't look such a great decision anymore, huh? So, but I have a backup, right? The plan was, if that doesn't work, we'll just slam in the one that does work, and it's identical, right? Let's see if anyone in chat has debugged my problem. Nope, not yet. So let's see. We put the mammoth. Alright, what if we take the AI out? Take the AI out. It should go back to working, right? No. Curious. Alright, what if we take the whole mammoth out? No. Oh, breakpoint. Nope. That's really strange. So I did something while I was like showing you guys a tour of the tree, which broke everything, which is disappointing. Is the whole game broken? If I don't run our test. I wonder if it's just XSplit. Does anyone else see this green bar on the left side of the screen? Like here, if I get a game full. Oh, wow. XSplit is totally hung. Alright. Wow. Whoa. Git checkout file. Don't check out my code. Wow, XSplit is not happy. Where did this sound go? Audio died. Yeah, XSplit is down. Alright, I gotta restart the stream. I'm gonna restart XSplit and hope it works. Let's see. Alright, be back. I think XSplit is killing the game somehow. Am I still broadcasting?